Welcome to your course on artificial neural networks. We will start this course by having a brief introduction about data science. Data science is probably the hottest buzzword in the industry now. An article in the Harvard Business Review puts data scientist to be the most exciting and high-paying job of our time. Data science is the art of turning data into actions. This is accomplished through a creation of data products which provide actionable information without exposing the decision maker to the underlying data or analytics. For example, buy or sell strategy for financial institutions, a set of actions to improve the product yield, or steps to improve product marketing. As this Venn diagram illustrates, data science lies at the intersection of three important skill sets: hacking, mathematics and statistics, and domain expertise. Any one or any two of these skill sets take you to another domain. For example, hacking skill along with mathematics and statistics takes you to the domain of machine learning. Although machine learning is a key component of doing good data science, it does not take domain knowledge into account. Having this expertise will not only help you get better with machine learning, it will also help you make sense of complicated black box mathematical algorithms. On the other hand, a lot of mathematics combined with domain expertise makes up a traditional researcher. So, data in the modern digital age comes in various different formats, from text to images. Data can be structured, semi-structured, or without any structure at all. The most attractive part about doing data science is machine learning. Now, machine learning is the art of extracting patterns and insights from data and predicting the future based on historical data. A common goal in machine learning is to make a computer learn from some historical data points and allow it to build its own judgments based on some mathematical algorithms. Machine learning is most helpful in automating tasks that are overwhelming to be done manually or prone to human errors. For example, fraud detection for credit card companies is too big of a problem to be solved by human inspection. Consider the number of credit card customers the biggest credit card company would have. It's not feasible to do real-time manual checks of all transactions happening on active credit cards. This is where machine learning comes into play. Based on the historical data on fraud transaction, it can identify trends and patterns that are not otherwise visible to a naked eye and help identify potential fraudulent transactions. Over the years, there have been many definitions of what is and what is not machine learning. Two perspectives from two pioneers of the field stand out. The first one by Arthur Samuels way back in 1959. It's sort of an abstract definition, which claims machine learning to be a field of study that gives computers the ability to learn without being explicitly programmed. The second definition, which is much more recent, comes from Professor Tom Michel from Carnegie Mellon University. Professor Michel talks about an experience that a computer learns from performing a task which has an associated performance measure with it. The machine can learn if its performance in doing a task improves its experience. Now, here are some examples of machine learning from our day-to-day lives. If you note that Gmail can mark certain emails as spam. The spam filtering is one of many cases where machine learning has been extremely helpful in achieving great results. Not just Gmail, any popular email service provider that you use nowadays can mark emails as spam or not spam with a reasonable degree of accuracy. If you ever wondered how popular e-commerce websites can come up with surprisingly good recommendations for products that you wish to buy, this is again done by some very clever applications of machine learning algorithms. Also, machine learning algorithms can now classify handwritten digits with nearly 100% accuracy. Add to this the ABS on your cars, autopilot on Tesla cars, self-driving cars from Google, all of them. The list is pretty long. Although we do not get to see the details of every application, machine learning has touched all of us in one or the other way. This field is not a new field by any means. Over the last couple of decades, machine learning has combined ideas and methodologies from many different fields like probability and statistics, computer science, computational biology, things like that. Probability, statistics, and computer science, they form the backbone of modern machine learning theory. It also borrows ideas from biology, genetics, clinical trials, and many other fields from social science. Now, the advent of modern computing power has actually helped in spurting of machine learning. Now, anyone with a credit card can span up a cluster from one or many web services that are available. Now, it can be from basic to advanced specification of clusters, which actually makes up an enterprise class hardware available to a consumer in a fraction of a few minutes. Now, additionally, good results on problems considered difficult to solve historically has given machine learning a lot of popularity in press, and moreover everyone seems to be talking about it, right?